Okay, another day, another dollar. The world is burning, but we're going to continue working on our compiler. Okay, I did a bunch of stuff off camera. First, we got a basic type system, so you can see the types translate to primitive C types translate to sorry, primitive types translate to C types. We also got array declarations going. So this is a empty array that's zero initialized with 12 signed 32-bit integers. So that's cool. Yeah, we can also initialize numbers. I'm not sure if I showed we got if statements going, but that could be in the previous recording. We got update statements. I'm pretty sure I already showed that. Yeah, we got multiple statements. It will break, unfortunately. I mean, I've thought about ways to deal with it, and like the way I want to deal with it is pretty fiddly. So like, if we go to our AST, uh, what am I looking for? I'm looking for a block. So a block has a list of any statements, and any statement is a tagged union containing just a bunch of pointers. Um, so if we go to the parser, and we go to parse block, probably body. Should have called it that. We just make a slice of 8 statements and then just call it a day and index into that, and that's not what we want to do. So I've thought of a way you kind of just use the temporary arena allocator as a stack, and then you can allocate an array off the stack, and you just got to guarantee that whenever you're returning into a function, it's at the same state it was before. And that way you can just use the stack to allocate like a continuous list of any statements. Um, However, uh, it's kind of difficult to do this. This is like the one thing I'm not sure about Odin. Um, I'm not sure about like the context system, because I think having like explicit allocators, and not just like explicit allocators in the way Zig has it, but having explicit allocators where you like 100% know the implementation details, it allows you to give better solutions to your problems. And so I'm not sure about having just a generic interface. Like, what I want to do is I just want to have, you know what? We could just do it like the handmade style, and I don't know what would call it, uh, misc.odin. Uh, and we'll just have a global variable in it. Or can we do thread local? Is that a thing in? We'll get to that bridge. So we'll just have a global variable. Mm, And we want a scratch. Scratch allocator. We'll just have a procedure called get scratch. I don't think it needs any parameters. And we can just return. Like, here's the thing. Base, used, committed, reserved. And this is based. That is based. Oh yeah, I guess I should explain what we're doing. Brain fog. We want to we got to do dark mode. Basically, right, we have the we have the we have the stack. I haven't prepared this, so I don't know what I'm gonna do. Okay, let me think for 1 second. Okay. We have our statement allocated here on the arena. So this is like an if pointer. We go do a call to another function. So this is in parse body, which really should be called parse block, but we can fix it right now. It's better to do it early than to have just so much cruft. Then we go do some other stuff, and we do a bunch of other temporary allocations, and we pop that off. And then we push on like another statement. This would be, let's say it's like a plus equals. A var decal pointer. And at the end, we have like this continuous list of statements, and then we copy that, put it onto the main arena that we're allocating it, like the context.allocator, not the context.temporary allocator. But in order to do that, we need a way to allocate an array without allocating an array. Like we just want to allocate these individual components at a time. And then slice into that. So I could do some funky stuff. But yeah, I don't know. All right. What else we want to do? I guess we should go to our plan. Um, okay, I don't think we have enough time because this is a short one to do like for loops and all that kind of like adding actual functionality that's improves upon C. But I think today what we'll do is add array initializer. So we'll go 1, 2, 3, 4, 5, 6. To do make a easy initialization. And the thing is, I don't actually like this. Like, I think that's the reason why this is better, because when you get to here, you can be like, okay, are we expecting a comma? Okay. Do this. And this is like, I guess like an expression block. Um, that might not be the best thing to call it. I guess we could just call it like a list, an expression list, because these can contain expressions. They don't have to contain all constants. So, but to do that, we probably also want to do like implicit declarations, which I kind of don't want to do. So maybe this isn't the right thing to focus on. Maybe we should maybe what we'll do today is we'll do for I and 0 dot dot less than 10. And then we'll get the factorial and it's an integer. I think that's right. Um, or for 0 to n, x times equals n times equals n minus 1. Yeah, I think that works. Then we return n. And what we want, or no, I'll just write it out, is we want int factorial int n for int I equals 0 while I is less than n, I plus plus n times equals n minus 1, and then return n. So that's what we want for it to compile, and it should look like that. Okay, so we're gonna need 4, we're gonna need in, we're gonna need this. Into the tokenizers, so okay. Yeah, I guess let's get to it. So I'm not gonna do this actually. Boop. Tokenizer. Okay, we want to go into tokenizer map. We want 4. I'm stupid. Control flow. Yeah, we'll put this here for now. Four. In. And okay, we go to the tokenizer. So we got those two added. And now we need the dot. So do we have a... Nope, do not. We'll add that after, before the comma. The world's burning. The world's burning. I also don't know where to put this, but we need to put a dot. Well, we don't need to, but I want to. Okay, t dot curve plus equals 1. We'll just have a giant Do we have advanced character here? No. It's in my second version. I guess we didn't. What should we name it? Range less. Um, what I am to be lazy. Okay, we got that. We want to go to the parser and we want to go to parse body. Okay, parse the statements. We have an identifier. We have an if. And we go here. Okay. Uh, feels good to program. I haven't been programming in a while. I guess I should talk more. Um, so the tariffs are coming in on Tuesday, and that'll be fun. I don't know what I'm gonna do. Um, yeah, times are tough. Uh, Tuesday or Wednesday, it's the 4th, which is a Tuesday. So 4i advanced token. Okay. Um, Identifier talk. This is such ugly code. Mm, Actually, no. Uh, Parse expression. Mm, Dark times like this, we gotta be strong. maybe just a little bit would be fine. Left brace. It's the AST. I really love this programming language. It's so easy. Okay, we get the condition. Okay, after we parse the expression, we should skip new lines. We should advance the token, skip new lines again, and we gotta go. Long. And then on the block, we encase it. Okay. God damn. Okay. I was hoping that it would work, but that's fine. We should expect range less and advance the token. Less than. Range less. Oh, okay. Okie dokie, okie dokie, okie dokie. Okie dokie, Pinocchio. $41. How do we get to 41 tokens? This might be a debugger kind of thing. Anyways, I'm gonna end for now. This probably won't be a whole video, but we'll get back to it later, maybe tomorrow. I have some homework. I'm a college student, so good night. Okay, so I got it working in like 5 minutes, so this is actually the end of the video. Bye. Okay, another day, another dollar. The world's kind of... it's turning right now. That's for sure. I guess today, maybe we want to do, like, struct declarations and, maybe add slices. Actually, yeah, let's add that would be good, right? So I don't think we need any more tokens for that. Zoom one out. don't think we have to modify the tokenizer at all. We just have to go to... so we get the left bracket. That should be good. I think we gotta start on some semantic analysis, like type checking and making sure like local variables are like chill and all that. So hold on. So we're gonna need to resolve implicit I don't know how to spell it. Resolve implicit type inference. We gotta check types. Oh, another thing we should do is we should add function calls. Um, so function call looks like this. So it's an identifier followed by parentheses. And I can't think of a case where that's not all of it, but like sometimes that's not true. So maybe I guess we gotta do a after AST generation, we gotta make a typed AST tree. And ambiguous declarations are put in a registry to check how to resolve the declaration. We're just gonna go with a dynamic array for now. A lot to do to make scheme so, such that we do not need a dynamic array. And then we also need a queue. Priority queue. Type ID. Okay. Okay. I think it's about time we consult the Odin implementation, because I'm or no, we want AST. Okay, we're gonna do stuff up front. And we're gonna do it because we like to do hard things, and in hard times we gotta do stuff to accomplish that. So, we're gonna have a type node, and we don't need any of this. And we're gonna import core container slash intrusive slash list linked list. This is a struct. And it also has E. We'll have a bunch of no, we don't know that. Need that. Resolved. Unresolved. And yeah, we're probably gonna need some other stuff, but let's add, I guess, some implicit stuff. So, oh yeah, I guess we should check if our slice shit works. And we also... got a... find a way to do this. Declaration. So I think in C we can have... I gotta look up how to declare anonymous structs. Okay, so I think we can just go like this. So I think we can just go like that. And then we do yeah, okay. That works. Become parser slice.